This trigonometry, okay, chapter 8. Now, what you need to know is this. If I gave you this here, 4 and 3 are the lengths of these two sides, okay? The first thing you're going to be asked is, how would you get the third side, the length of L? Length of L is gotten using Pythagoras' theorem. 4 squared plus 3 squared, L squared equals 25, L equals 5. That's what it is there. Okay? Now that this is done, what we got to do next is you got to be able to, you got to be able to do the following. You got to be able to write down what cos x is, sin x is, tan x is, and you also got to be able to write down what cos theta, sin theta, and tan theta is. Now, the one thing that never changes is the hypotenuse. So hypotenuse always remains the same. It's always the longest side in the triangle. However, what's the opposite and the adjacent changes according to what angle you're talking about. So, for the angle x, which one is the opposite? And which one's the adjacent? 4. Cos, so, ka, toa. Okay? Now guys, what is adjacent over hypotenuse for x?
Cosine.
4 over 5. What is it for sin x? Opposite over 3 over 5. And what is it for tan x? Sorry? 3 over 4. Okay guys. Next thing. What's cos theta? Adjacent over hypotenuse. Cos theta? 3 over 5. Sin theta? 4 over 5. Tan theta? 4 over 3. Stop there. Now guys, I'm going to find out the angles. Now, how do I find out the angles of, how do I find out angle x and angle theta? I'm going to show you now. I can use any one of these I want. See, cos x equals 4 over 5, sin x equals 3 over 5. What you do is, cos inverse 4 divided by 5. It tells me that the angle in question is 36.87. What happens if I use tan inverse instead? Tan inverse 3 over 4. Huh? Once again, 36.87. Now guys, look what happens when I compare. So this is 36.87. That's 90 degrees. And we could just add them together, take it away from 180 to find out this other angle. But look what happens when you turn them upside down. This one is 3 over 4. But this one here is 4 over 3. So let's see what happens to tan inverse 4 over 3. $53.13. The bottom line is, when you turn tan upside down, whatever angle you used to have, take that old angle away from 90 and you get the new angle. So for example, look at this, okay? We originally said that x is 36.87. X has to be equal to 90 minus theta. Why is that? Because if this is 90 degrees, x plus theta must equal 90 degrees. This means that x is equal to 90 minus theta. And what do we say? So therefore theta must also be equal to 90 minus x. Now what's 90 minus x? 53.13. That's exactly what tan inverse 4 over 3 is. The next thing we're going to be dealing with is angles of depression and elevation, okay? So, show you this now. Sorry guys, this is chapter 9, is it? Sorry, chapter 9. Okay. Now, okay, imagine this guys. I have a question here. Okay, and it looks like this. Here's my question. Okay? And in this question, a person is looking up, okay, and another person is looking down, and the other person is sort of lying down, so his eye level is up there, okay? Now guys, he's on top of a building, let's say, okay? Now, what happens next is, guys, the building is 5 meters tall, and the man is 12 meters away from the foot of the building. Now what happens is, I gotta find out this angle here, theta. Okay? To find out theta, I know is that I know the opposite, and I know the tan theta equals 5 over 12. What can you tell me about theta then? You can find out what it is, can't you? Tan inverse 5 divided by 12. And what do we get?
22.6.
22, round it off to one decimal, 22.6. Now, this here is an angle of elevation. Do you got it? 22.6 degrees up. Okay? Now, the person looking down, why is this angle also 22.6?
Because those two lines are parallel.
Alternate angles. Okay? Alternate angles. When you have two parallel lines, like so, the angle in between here and here have to be the same. Okay? So this is what's called an angle of depression. Now what's the angle of depression of the person looking up here? 22.6 downwards compared to 22.6 upwards. Finally, okay guys, next thing is north, south, east and west. Okay, you have your anybody doing applied maths would know this, right? If you have an angle going this way and the arrow's moving directly upwards, and I say this here is 30 degrees, what is its direction if you're using compass? North, 30 degrees, east. Or can anybody give me another one?
East.
Yes.
70 degrees.
60 degrees. North. Okay? Because you're going east and then 60 degrees upwards. Or you're going north and 30 degrees downwards. What about this direction here? What about this direction here?
South 40 degrees east.
South 40 degrees east or?
East 40 degrees, 60 degrees south.
50 degrees. You have to add up to 90. Take it away from 90. South. Is that alright? Yeah. Okay guys. Finally, one last one. What happens if I say it's 45 degrees?
It's 45 degrees.
It's north-west. North 45 degrees west or west 45 degrees north. Okay, handy enough. Alright guys. Okay guys, this question here. A vertical building on horizontal ground is 5 meters tall. The building requires an outside support beam to prevent it from collapsing. The maximum amount of space to erect the support beam is 12 meters to the left of the building. So look guys, this is the support beam here, okay? Using the diagram, calculate the maximum length the support beam can be. So guys, if you set the support beam out here, that's at 12 meters. That is automatically its maximum length. If I set the support beam in here, it'll be at a much higher angle, but it won't be as long overall. So what we're looking to do is we're looking to do Pythagoras' theorem, find out what is the length, we call it x. X squared equals 5 squared plus 12 squared. X squared equals 169. X equals 13. It's a length of 13. Okay? Okay. An engineer calculates that the support beam reaching up a height 4 meters in the building would be more effective. Find correct nearest to nearest centimeter the maximum length of this support beam. Once again, instead of going 5 up, we're now going 4 up. In effect, we have a triangle that looks something like this. We have a 12-4 triangle like so. 12, 4. Once again, we're going to find out what the new length L is. L squared equals 4 squared plus 12 squared. L squared is going to equal the square root of 160. What's the square root of 160?
12.75.
Is it?
I'm guessing. I'd say so.
Don't guess. 12.65. 649. Now guys, 12.649 is this. It's 12 meters, 65 centimeters. Okay? Further analysis indicates that the optimum best angle for the support beam is 45 degrees to the ground. Find correct nearest centimeter, the length of the support beam if the point of support is 4 meters high. Now guys, there's something you need to know about 45 degree angles. When you have a 45 degree angle, what happens is, when you have a right angle, and I'm told that this here is 4 meters, like so, you're looking, this is 45 degrees, that means that this one up here has to be 45 degrees. What type of triangle does this make this? Isosceles, which means that also has to be 4. 4 and 4. Goes, find correct near CM, the length of support beam if the point of support is 4 meters high. We now have to do Pythagoras' theorem, and this time we're going to get, what are we going to get? We're going to get 4 squared plus 4 squared, which is square root of 32. And when you said that is what, Simon? 5.65, which is 5 meters, 65 centimeters. Finally, give one reason why you think this mathematical model would be suitable or not in practice. Pythagoras' theorem is a very quick and effective way to find out the maximum length of the whole point of this exercise was to find out the maximum length of the support beam. Pythagoras' theorem is a quick and easy way to find out the maximum support beam because it's much easier to measure the height from the beam to the foot of the base and the height going up the side of the building as opposed to diagonally trying to get measuring tape going taut straight across. That's why it'd be an effective model in practice. Alright, so guys, what you guys are going to be doing in class is we're going to try all the odds, okay?